Hello and welcome to my channel. Today we are going to discuss the Python context managers, also known as the with statement. The with statement in Python is regarded as an obscure feature by some, but when you peek behind the scenes, you will see that there is no magic involved. And it's actually a highly useful feature that can help you write cleaner and more readable Python code. So what's the with statement good for? It helps simplify some common resource management patterns by abstracting their functionality and allowing them to be factored out and reused. A good way to see this feature used effectively is by looking at examples in Python standard library. The built-in open function, for example, provides us with an excellent use case. Opening files using the with statement is generally recommended because it ensures that the open file descriptors are closed automatically after program execution leaves the context of the with statement. Internally, the above code sample translates to something like this. Wow! Now you can already tell that this is quite a bit more verbose. Note that the try finally statement is significant. It wouldn't be enough to just write something like this. Any idea why? Exactly. This implementation would not guarantee the file is closed if there is an exception during the f.write call, and therefore our program might leak a file descriptor. That's why the with statement is so useful. It makes properly acquiring and releasing resources a breeze. Now, there are many examples of context managers. We will dive into the code now and look at a couple of ways of how we can define our own context managers. So let's do that. Now, there are a couple of ways you can implement your own context managers. One is by using the classes, and the other one is by using Python standard library module called contextlib. We will have a look at example from each of them. So let's start by implementing a context manager using a class. So let's say we need to implement an indenter that indents the code to the right on each entry of the context and indents it to the left on each exit. So how do we implement that? So obviously we'll have a class and we can define the constructor, and within the constructor we can define the indent level initially set to 0. Now what we want is that on every entry of the context we increase the indent level by 1, and on every exit we decrease it by 1. So how can we do that? Well, it's simple. The magic methods, also known as the dunder methods. For this case, there are two methods: enter and exit. So as the name states, enter refers to what happens when you enter the context. So we know in this case we just need to increment the indent level, and on the exit we need to decrement. And let's say we actually have another method called print for this, and we simply print the message indented by the number of tabs. So here we can have something like this. Now let's try it. We'll change the messages. and let's give it a run. Wow, look at that. So as you can see, on each entry it's indented the text one tab to the right, and on each exit it has brought it back. So, well, here's your example of how you can implement a context manager using a class. Now, writing a class-based context manager isn't the only way to support the with statement in Python. The contextlib utility module in the standard library provides a few more abstractions built on top of the basic context manager protocol. This can make your life a little easier if your use cases match what's offered by the contextlib. In our case, we are going to implement a context manager that prints out the number of seconds it took for the code block within the context to execute. For this, we're going to import the decorator called context manager from the contextlib module. We're going to make use of the time module. And for writing our context manager, first of all, we need to decorate it with the context manager decorator. Let's call our context manager time it. And then we define what happens when the control enters the context. So we're going to just note down the time when it happens. Next, we need to release the control using the yield statement. Once it exits the context, the control will come back here. What do we need to do here? Well, simple enough. We just calculate the time it took for the execution. And then we just print it out. Now let's make use of this. So we time it, and then we can have a simple expression, and let's make this go to sleep for a couple of seconds to actually see this in action. Let's run it. Here you go. So as you can see, it took a bit over 2 seconds for this code block to execute. Now these are a couple of examples of how you can build your own context managers. Okay, here are some final thoughts. So using the with statement simplifies exception handling by encapsulating standard uses of try, finally statements. And I think we have seen that in the start when using the standard library function open. With statement is mostly used to manage the safe acquisition and release of the system resources. You can actually acquire a lock and release a lock in a multi-threaded environment. Using with effectively can help avoid resource leaks and make your code easier to read. Now guys, help me improve the content. Hit the bell icon to subscribe and comment on how I can improve the content, or if there is anything that you would like me to cover. Ciao.